Welcome to webinar 2 of BioData Catalyst powered by Terra. I'm going to be shortening this to Terra for the purpose of the presentation, but know that this refers to BioData Catalyst powered by Terra. I'm Liz Kiernan. I'm a science writer at the Broad Institute, and I'm very excited to participate in your second onboarding today. Just a few logistics before we dive in. This should look pretty familiar from webinar 1. We're going to encourage you to ask questions in the chat in real time. We have TAs available who will be able to answer your questions. So feel free to either message everyone on the chat or the TAs directly if you want to send a private or direct message. TAs will have a label in their name as TA, so you should be able to identify who is a TA. We have Allie and Kate who are helping today, and Tiffany, who's also one of the speakers today, and myself, so we'll all be able to help answer questions. And TAs, if you could just raise your hand real fast too, so that people can see. Thank you all. Okay. Which brings me to my second point, which is today we're going to be using the raise your hand feature. We have several hands-on exercises, and so we're going to be using that feature to make sure that everyone's on the same page and that we're ready to move forward. So if everyone in this webinar could try it out right now and raise their hand. Okay. And just so that you all know, when you do raise your hand, it will stay up until you lower your hand, which is kind of a handy feature for us. So if you want, you can take your hand down now. Great. So thank you all for participating in that. The last thing I wanted to mention for today is that all the materials that we're using today are going to be available at this broad.io link, including the slides that I'm using here. Okay, so for today, we have a pretty full agenda. We're going to kick off this workshop with writing and running workflows. So we're going to give you a brief overview of WDL and workflow submissions, and then we're going to give you some hands-on exercises solving some WDL puzzles. Then we're going to dive into configuring and launching workflows in Terra. So we're going to take those puzzles that you solve in the first section and actually configure them to use data in Terra. Then we're going to jump into troubleshooting workflow submissions, and we're going to end with some advanced WDL concepts. All right, so a quick status check. If everyone could raise their hand if you completed the homework or the pre-work for today's workshop, and that included a Learn WDL video tutorial and the Data Tables Quick Start parts 3 and 4. All right, great. Okay, so great. So most of you completed the pre-work, some maybe didn't have a chance to, and that's okay. I did want to just emphasize that if at any point we're moving too fast through the material, we can slow down, reach out to the TAs, we can go over concepts more thoroughly based on the need. So don't be alarmed if you didn't do it. I do recommend completing it in the future because it's very helpful, and the material that we're covering today will make more sense with that pre-work done. So, and just to remind everyone, based on last webinar, from webinar 1, you should now feel a little more comfortable with the concepts of cloning a workspace, importing data, and running a basic workflow. Okay, so with that, let's jump in to writing and running our WDL workflows. So as many of you probably know at this point, there are basically 3 components that we need to run a successful workflow submission. We need a Docker container, which is essentially a package of all of our software and its dependencies. We need a workflow written in WDL, and of course we need data. So let's talk about the first component, a Docker container. So as I mentioned, Dockers are basically portable packages that contain the software that you need in order to perform different functions with your workflow. And you can find these Docker images on different public registries. So if you have a software need, it's likely, if you're using a common bioinformatic tool, that someone else has posted a Docker image with the software that you need. So we do recommend searching and finding Docker images that may have the software that you require. And some common public registries include Docker Hub, Quay.io, and the Google Cloud Registry. Now, if you're using a unique piece of software or maybe a version of a software that is not so common, you do have the option to create a Docker image as well. And we're not going to go into how to create a Docker image today, but we have 2 tutorials that you can look at and explore if you're interested in building a Docker file and publishing it to a registry so that you can use it in your WDL workflows. The first one teaches you how to build from a Terra base image based off of our Jupyter notebook Dockers that are available. And the second tutorial teaches you how to publish a Docker file to a public registry. So if you're interested in learning how to build your own Docker files, I recommend using these 2 tutorials as a starting point. And these are both links. So again, if you go to these slides, you'll be able to check them out. Once you find a Docker image that meets your requirements, you can use that Docker image interactively, meaning you can open it on your local, your personal computer, and make sure that it is actually doing the functions that you need it to do, that the software is working the way you expect. And once you've kind of tested that and interacted with it a little bit, you can put it in your WDL workflow. And we do this by specifying a Docker image in the runtime section of our workflow. And we'll show you some examples of this today. Okay. So that was a lightning tour of Dockers. And now we're going to give a brief overview of WDL workflows. And if you've done the homework, hopefully this will be quite a bit of review. So WDL stands for Workflow Description Language. This is a human readable processing language. And on a high level, basically what it does is it takes in inputs, it calls tasks to perform commands on those inputs, and it produces outputs. Every workflow starts with a workflow definition. So here you're seeing an example of that here with my workflow name. You can specify inputs and their types. So here we can see some files and some strings. And in your workflow definition, you call your particular task. So here you can see we're calling task A and calling a task B. Tasks can be defined in the main, right next to the main WDL workflow definition, or they can actually be written into their own WDL scripts. And tasks look pretty similar to WDLs, to the workflow definition, in that they also take in inputs, but they have some additional sections to them. They'll have a command section. This is where you actually take in your inputs and tell your software essentially what you want to do with it, the software that you're using. This is very similar probably to some command lines that you've used on your personal computer. It also has a runtime section where you specify, again, that Docker image that you're using, that Docker that contains the software that you need. And it has an output section. So that's kind of the high level of what a WDL script looks like and what it can do. So how do you actually run these on Cromwell? Cromwell, as a reminder, is a portable execution engine that can run WDL. It can also run the Common Workflow Language, CWL. And Cromwell essentially has 2 modes that you can run in. The first one is run mode. You would do this from your local or personal computer. And then there's server mode, which you're going to get an example of today when we use Terra. Terra uses server mode. So in run mode, you can run a WDL on Cromwell using a simple self-contained command, like the one you see here, where you take in your script and you define some inputs for it. And you would want to use run mode for basically independent analysis. Let's say you just want to test your workflow on a small subsampling of data, make sure that it works appropriately. Those are good use cases for using run mode. Server mode, like the one in Terra, is a little bit more scalable and better for production. It has web-based API endpoints. Because it's using the cloud, it's more scalable. And server mode also has a feature called call caching. And this is a cost-saving tool in that what call caching is if you run a workflow that takes in certain inputs, if you need to rerun that workflow, if your task has already run successfully, it won't actually rerun. It'll just use the previous outputs generated from that task. So in other words, if something is run successfully, it doesn't run it again if you're using the same inputs. And this can be handy, especially if, say like a task fails in your workflow. You don't need to rerun all of the tasks leading up to that task in order to try the task again. So anytime you want to repeat your workflow, this is a very handy feature. All right. So let me talk a little bit more about run mode in case you do want to try running a WDL workflow on Cromwell on your personal computer. There's basically 3 steps that you need to take. First, you need to validate your syntax. This should sound familiar from the Learn WDL videos that were homework. You can use a common tool called WOM tool, which will validate syntax in WDL scripts. Once you validate your syntax, you will want to generate an input JSON. So that is a configuration file that takes your input variables and you can assign those input variables to some attribute. WOM tool, in addition to validating syntax, can be used to generate this configuration file for you. And so here you see that we're making an inputs file called hello inputs JSON. So once you've validated syntax and you have your configuration file, you can then run your workflow again using that standalone command where you take your WDL and you specify your inputs. So that's how to run in run mode. And again, we're going to get practice with that server mode form later on when we actually work in Terra. Okay, so that again was a very fast overview. And hopefully looked familiar if you had done the homework for today's workshop. But now we're going to dive into the WDL puzzles that we're going to be using today to get a little bit more practice with WDL scripting. And we have 2 puzzles. One I'm going to demo for you, and then we're going to give you an advanced puzzle to do. So what WDL puzzles are essentially real workflow, WDL workflow scripts that are missing some pieces in them. And so we need to identify the missing pieces and put in the appropriate variable names. I'm going to, again, demo this first. So at this point, you can just watch as I walk you through how we're going to do this. I do have instructions on the slides in case you want to come back and try this for yourself later. But again, for the demo part, you can just watch me for right now, and then I'm going to give you time to do all of these steps after this little demo here. So the first thing we're going to do is go to the WDL Puzzles workspace. And again, we will give you the links and everything to these workspaces in a moment. So this is the WDL Puzzles workspace. And the first thing that I want to do is make a clone of this workspace. So I'm going to go ahead and do that. And I'm going to append the workspace with my name, today's date, and a meaningful word here. For the billing project, you should have a billing project available to you or the workshop temp as a backup. And then I'm going to hit clone. All right. So let me just tell you a little bit about this workspace. When you come to this workspace, you'll see in the dashboard a high-level overview of the steps that we're going to take today in our different exercises. And if you want more detailed instructions, including the answers to the WDLs we're going to be using today and how we get to those answers, there are detailed step-by-step instructions available in our knowledge base. So you can follow those after today's workshop by going to the link here. But hopefully today, just by following what I'm showing you, you won't need to refer to these instructions. The data tab of the WDL workspace, WDL Puzzles workspace has several tables that are pre-loaded for you. We're going to be using these tables in the second section of the workshop today. And if you go down to the other data section of this data page and click on the workspace data table, this is where we can actually find the WDL puzzles we're going to be using today. So you can see that there are 2 here, an advanced puzzle and an easy puzzle. So we're going to be downloading the puzzles from this workspace data page. Before I do that, I also just wanted to show you the workflows page on this workspace. One of the exercises we're going to be doing today is importing a workflow into Terra. So I just wanted to point out that there are 2 workflows that already exist in this workspace. These are the answers to both the scripts and the configurations, so don't peek at them too soon. But I didn't want you to be surprised when you see 2 workflows that already exist in here. All right, so now I'm going to return to the data page on this workspace and download the easy whittle puzzle, which is what I'm going to use for the demo. And again, you will be using the advanced puzzle. So when I click on the link for the easy puzzle, I have the option to download it. And I'm going to open this puzzle using a text editor. All right, so let's take a look at what this whittle puzzle is. So this whittle puzzle is a hello world workflow, specifically called hello input. We can see from the workflow definition, starting here on line 3, that what this workflow is doing is it's taking in some input in the form of a string. We don't know what the variable name of that string is yet because it's missing, but we take that string and we're going to call a task called write greeting that has an input, and then we're going to be outputting a file that's some sort of write greeting response. And if we look at the task, we can see that what the write greeting is doing, it's taking in a variable called name, and it's echoing the phrase hello name input. Okay, so what we need to do to solve this puzzle is look at our workflow, both the definition and the task, and identify what the variable name should be for this string. So I'm going to actually ask you, the audience, what you think that this variable should be. Please feel free to just paste it in the chat, or you can directly TA or message a TA. We have answers. That's great. Okay, so for those who answered, would anyone like to say how they knew that it was name?
That it's the first variable that's called afterwards by write greeting, and it's called throughout, so you need to define it.
Yes, we can look at our call thing in here and we see that we have this input. This is the task input name, and it's being assigned to a variable name. So this variable has to come from someplace. Yeah, thank you very much. Okay, so we're gonna save the puzzle. I'm just gonna save it so I can easily pull it. Okay, so once you've solved your puzzle, you're gonna save it. And then what we're gonna do is we need to get our whittle scripts into the cloud so that we can import them into Terra. So we're going to specifically upload our scripts to the Broad Methods repository. So in case you haven't seen this, I want to show you that you can navigate to the Broad Methods repository by going to your main menu, going to the library section and workflows. You can from your workflow code and workflow section, you see the Broad Methods repository over here to the right. So you can access this from Terra. Or we can give you the direct link, which the TAs can put into the chat, just to go directly to the Broad Methods repository. Once we're on the Broad Methods repository, we want to create a new method. So I'm going to go ahead and select Create New Method. We have to give a namespace to this method. That's basically a folder to keep things in. I'm going to give the namespace April Demo. And a name for our whittle, which I'm just going to call Easy Puzzle LK. All right. Then we need to load our whittle script from file, or you can actually copy and paste into this block. So I'm just going to choose my easy puzzle that I solved and open it up. Okay, so there it is. Now this box, this is actually a text box that's editable. So we could change things around just by editing in the box here. So really fast, if you're watching, I changed my string back to the ellipses here. I'm going to try uploading this whittle script with the syntax here incorrect, just to show you what's happening in the background when you load a whittle script to the Broad Methods repository. So I'm going to skip this optional documentation section, this synopsis and snapshot section, and just try to upload directly. And we see when we do that, we get an error. And that's because in the background, the Broad Methods repository is running WOM-tool to validate our syntax. So I'm going to go ahead now and change this back to the correct variable name and try to upload it. Oh. Uh-oh. Well, that's not happened before. What did I do?
Maybe somebody's used that name before.
That was
Yeah.
me. I'm sorry. I jumped the gun and wasn't sure if namespaces were exclusive to your user or global. My fault.
No worries.
Okay.
Well,
Yeah,
now we
thank you
know.
for-
Now everybody can see that.
Yeah, so this has to be unique. This has to be unique. So good to know.
Can I delete it? Is there any way to delete it?
I am not, I think there is a way to delete a namespace, but we don't need to worry about it right now. You know, if everyone's worried about it, just maybe put your initials and the date or something with it. But I'm just gonna, the namespace isn't so important. I have a lot of namespaces, so. Okay. I shouldn't say it's not important. It's not important if you're just doing a demo like I am right now. If you're trying to actually make your workflow public to the world, it could be important. But okay, so here I am. I've uploaded my WDL script successfully, and now I'm going to export it to the workspace. It's going to ask me if I want to select a method configuration. We haven't made a method configuration for any of our puzzles, so we're just going to use the blank configuration. And then it's going to load some destination workspaces. I could change the name if I wanted to here. And I'm going to choose my WDL puzzles. Yes. WDL puzzles and today's date. This one. And it says, would you like to go to the page now? We can go to the page now or not. And I'll just go back to my workflows here. So there we go. We see that it uploaded. I'm not sure why it gave me an error right there, but all right. So now if I'm back in my workspace, we can see that my easy puzzle LK, the puzzle that I just solved, was imported into my workspace. Okay. So that is just essentially a demo of the steps that we want you to take, but you're going to repeat this process now for the advanced WDL puzzle. So I'm going to go back to the slide deck here and pull up the instructions for today. So first, what we want you to do is just go to the workspace, clone it, and download the advanced puzzle and open it in a text editor. And when you all are ready and you've done this, please just raise your hand because then we'll review the WDL together for the missing pieces before letting you actually solve it. Okay. I am going to go ahead and open up the advanced puzzle and just show the missing inputs. If anyone is not ready to proceed and wants to be, please just feel free to scream stop or, you know, one more minute or so, and we can definitely give you some more time. Okay. So let me show you the advanced WDL puzzle here. So what this workflow is it's a validate BAM workflow that will, if we look at the workflow definitions starting on line 15, what we can see is that it takes in an array of BAM files, it scatters those files and runs a validate BAM task on them. And if we go down and actually look at the validate BAM task, we can see that it is specifically using a GATK Picard tool called validate SAM file. And it's outputting a validation report, validating the format for our BAM file. Now this advanced puzzle has several missing pieces. So on the workflow definition, you can see that it's missing some outputs, a variable name for our outputs. We need to assign this validation reports variable to some other variable. And if we look at the task definitions, we see several missing inputs. we see a file, 3 strings, and 1 string is optional. I'm looking at lines 50 through 53 if you're following on your own text editor. And we also see that our runtime parameter in our task is missing a string as well. So we need to identify which variable names to put to all of these. Okay. Are there any questions about the task? Okay. Then I'm going to put up the slide again here and let you all fill in those missing parts. And we'll come back together. I'm going to give you about 7 minutes to do this. So we'll come back at 12:38. Okay, we're at 12:38. So let's go ahead and review some of these answers. Let me close out of, jumping the gun. There it goes. Okay. All right. So I kind of wanted to walk through these answers together and kind of discuss a little bit about how we knew what these different answers were. So going down first to the task inputs that we're missing. Does anyone want to either put into the chat or unmute yourself for what the file, what the missing file variable name was? All right, great, thank you. And could you tell us why you knew that it was the input BAM? Oh, we have a question. Are we skipping past line 40 for now? Yeah, we're starting. I'm just going over the answers right now, and we are starting at line 50 for the task inputs. We're doing the inputs first, and then we're going to come back to what the output was. Yes, so if you looked at the inputs listed under the call, so if we go up to our workflow definition, line 29, where we call the validate BAM, we see that it specifies an input BAM for the task. And we see that that's assigned to a variable name called input BAM. If we look up here on the scatter part of our workflow definition, we see that we're scattering the files in our BAM array and giving each one of them the input name or the name input BAM. So that's how we know that this is going to be the input BAM variable name. What about one of the strings? Does anyone, or it doesn't matter which order, these 2 strings are. Okay. So one of these is output name, output base name. So I'm going to put that here. Base name. And now someone suggested that maybe output name was one of the other strings. And actually, it's not output name, although that is a variable that's used in here. It is, let's see, output name is used further on down, right? Yes, output name is used down here on our output. But I believe output name is defined up here. Let me just find it. Oh, there it is, string output name. So we've defined our string output name right here as output base name plus validation mode.text. So it's actually output name is not one of the variables that we're calling here. And we know that, that it has to be actually one of these input variables up here. So because these are the task level inputs that we're defining. So here we have output base name. So we know that that's the name of the variable in our task that needs to be defined. And so I kind of gave it away, but looking at that then, can anybody guess what the other required string down here in our task input is going to be based on looking at this validate BAM section up here in the workflow definition? Yes, that's correct. GATK path is our other one, which we've defined up here. Now we are still missing an optional string and a runtime parameter string. So does anyone know what the optional string was? Yes, it is validation mode. And one way we can kind of figure out that that is the optional string is 1. It's not a string that's called up here in our task. And also, if we go down and look where it's used in our command section here in this mode. And we see that we have a default already specified called summary. So if we didn't want to use the summary mode for this tool, which is set as the default, we could use our own validation mode that we specify with this variable. All right, and we have one more string that we're missing in our runtime parameters. So does anyone want to take a guess what that is? Or anyone know what that is? Yes, it's Docker. Docker. So again, our runtime is a section where we specify Dockers. And we see up here in our call that we have this string, or sorry, this variable name, Docker, that we're assigning to our GATK Docker that we defined up here in our workflow definition. Okay, so in general, when you're solving for these missing inputs in your task level input, it's always a good idea to go to your workflow definition, look where you've called the task and see what the task input names are, because they're always going to be here on the left of the equal sign. And we'll review that again later on in the workshop. All right, the last variable that we're missing is a variable name for our validation reports. We're assigning this validation reports output variable for our main workflow definition to another variable. Does anyone know what that is? Yes, that's correct. So thank you for answering. So it's validate, oops, sorry, validate BAM dot validation report. And the reason we know this is because we're looking for an array of files. Remember that we took in an array of BAM files. We split those BAM files up and ran the task on the individual input BAM files. And for each task that we ran, we got an output down here called validation report. So for every BAM in our file, we get one of these validation reports. So we need to tell, or we're stating here in the workflow definition that the validation reports is an array of files. So it's an array of each individual validation report. And we tell the workflow to get that output from the validate BAM task. So we say validate BAM, that's our task name, dot validation report. Validation report is the variable name that we've given to our output from our task. So that's how we know to put that down there. Okay, are there any questions about anything that you've seen so far in this WDL script? If validation mode is optional, what happens to the output name when validation mode is not defined? So the validation mode is defined. By default, it's going to be that summary mode. Oh, and I see you're saying right here in this input output name is the base name. So the validation mode is, yeah, it is going to be defined no matter what. But it's an optional input. So if you choose to give a different mode for your validation mode variable, it's still going to run this task. This task is still going to run. It's I hope that makes sense, because this is the mode here. The validation mode is defined. It's just defined with the default, which is summary. But you could optionally input a different validation mode into your workflow when you make your JSON file. So this is still going to be used for your task output. I hope does that make sense? And if not, maybe, oh, okay, good. I was gonna say maybe someone can try a better explanation. Okay, great. So go ahead, if you haven't saved this already, save your puzzles, and then we're going to upload them to the Broad Methods repository. And I'll give you about 2 minutes to go ahead and do that. I know some of you may have already done it, the step. So please raise your hand. Raise your hand once you've uploaded your workflow and exported it to your clone of the workspace. And then we'll move on to the next section. And again, we'll just do about 2 minutes here to do this uploading, but raise your hand when you've already imported your workflow into your workspace, and then we'll move on.
There's a question in the chat. Should the root entity type be set to participant? I think so. Just want to double check.
It can be set to participant. We're going to change the configuration in Terra. So that's why I skipped over that step. You can just use the default that's there.
Thank you.
Thank you. Good question.
One more question in chat. Could you show again how to upload the workflow?
Sure. I'm going to go ahead and go over here. So if I go into the Broad Methods repository, which does anyone need me to show accessing the Broad Methods repository again, or everyone has the link, I hope. Okay. So when you get to the Broad Methods repository, sorry, I've got my chats open here. Here we go. When you get to the Broad Methods repository, to upload the WDL, you're just going to go to create a new method. You're going to give it a namespace. That's essentially a folder name. It has to be unique from all the other participants that are here today. So try to come up with, your initials and a date. I'm just going to do demo again. And then the name for your puzzle. So you can call it whatever you want. I called mine OK puzzle, for example. So you can give any name you want to these as long as you fall within the restrictions here of only letters, numbers, underscores, dashes, and periods. To actually upload the file, we can either copy and paste the WDL script into here, because this is you can edit in this box, or you can load from file. So I'm going to do the easy puzzle from file. And then once you have your WDL uploaded, the rest of these sections here are optional. So I didn't show anything to fill in here. You could fill in some information about the script if you wanted to. And then we just select upload here. Once it's uploaded successfully, you can export it to your workspace. You want to use the blank configuration. And then it'll ask you for your destination workspace. You're going to choose the name of the workspace of the clone that you made. You can leave the name by default, whatever name you gave when you set up the WDL in the Broad Methods repository. You can leave the root entity type as participant. And then once you select your workspace, you can export to the workspace.
I guess I'm sorry I asked the question. I missed how you got to the Broad repository. Repository. Yeah.
The one step I was like, oh, I can skip that. Okay.
Sorry to interrupt. There is a link in the chat for it. The one that Tiffany shared should send you straight to the methods repository.
Perfect. Thank you.
Okay. I'll go ahead and just show it too really fast. You can access the Broad Methods repository from within Terra by going to the workflow section in your library, drop down from your main menu. And when you do that, it's over here to the right. So
Just to note that one day it will not be, the Broad Methods repository will not show FireCloud. It'll be accessible via Terra. This is a thing that we are migrating over slowly, but it is getting migrated over.
all right, I'm going to go ahead and continue. In case you were curious about the answers to those WDL puzzles too, I do have a slide in here. Whoops. With the answers, the results in there. So if you want to refer back to these slides after the presentation today, feel free to. They'll have the answers in them, as does the detailed instructions that were in the workspace dashboard. Okay, so now that you have imported your workflow to your Terra workspace, we're going to learn how to configure and launch that workflow in Terra. So specifically, we're going to be focusing on the third component that we need for a successful workflow submission, and that's our data. We have several best practices for configuring workflows using data in a Terra data table. So first of all, we do recommend that data tables be used for both your sample and your reference inputs. You can specify sample data tables in the table section of your data page, and you can specify references in the reference data and other data sections of your workspace, specifically also using the workspace data table. The reason we recommend using data tables for inputs is because it is an efficient way to organize your data. And it also is useful for allowing workflows to iterate over multiple files. So you'll see when we're configuring our workflows in Terra, you can manually specify locations for the files that you need for your workflow. But if you have, say, hundreds or thousands of files, you don't want to have to continuously, manually specify those in your workflow configuration. So data tables are, again, an efficient way to kind of iterate through many, many files if you're running your workflow on multiple samples. We also recommend that any workspace level metadata be put into the workspace data table. So this is metadata that maybe you can ask yourself, does this piece of information apply to all of my samples or many of my samples? If the answer is yes, you probably want to put that metadata into the workspace data table. Thirdly, we recommend that you write your outputs to the data table, and specifically Terra will write outputs to the root entity data table. And so we'll go a little bit more into that in a moment. But what this allows you to do is, again, you can organize your outputs and you can search data tables. So if you have thousands of outputs, you can maybe find the output for the one particular sample you need quickly. But it also allows you to chain workflows together if both your inputs and outputs are kind of in the same data table or in a data table that you can pull in to your workflow configuration. So let's say the workflow 1's output is being used for workflow 2 as input to workflow 2. You can pull all of that from the same place. So again, it's an efficient way that you can run multiple workflows. If you have general questions about configuring your workflow in Terra, we do have documentation that is linked to here that can kind of get you started and walk you through that a little bit better. But hopefully some of this is review from doing the data quick start parts 3 and 4 that was pre-work for the workshop. Now there is one thing that I wanted to touch on, which can be kind of tricky for new users in Terra. And that is the idea of when to actually use set tables versus an entity table. So that's saying, when do I use a sample table versus a sample set table, or a participant table versus a participant set table? Because not all workflows will require actually a set table as input for the workflow, as the root entity for the workflow configuration. So I just wanted to emphasize that also that not all sets that you create will be used as the root entity for the workflow. So what are some common reasons that we create sets? So commonly you can think of, if you have a data table where each row of that data table is a sample that you want to analyze with a workflow, maybe you have a mix of different data types in there. Maybe you have different species mixed in. So you have a couple of rows in your data table that are human, a couple of rows that are mouse, and you only want to analyze, say, the human. Same thing for participants. If you have participants in a data table where each row represents a file for each participant, maybe you want to divide that by age or disease state or other metadata. So that's one way that we can kind of think about creating a set in Terra where we just want to run the workflow on a set of files. Another way to think about this is maybe you have a data table where all the rows represent a subsample of a larger sample. So think about maybe you have multiple lanes of sequencing for one sample, and each row of your data table contains a lane of sequencing or a file for that one lane of sequencing. Okay, so that's just another use case for sets. So when do you actually need to use a set table versus an entity table for a workflow? And a simple answer for it is, if your workflow requires an array of files, so it's taking in an array, a set of files, and it produces one single output for that whole set, so one output file, then it might be necessary to actually use a set table for your workflow. And I'm going back again to that example of where we have multiple fast queues per sample, and say we want one BAM output for that whole thing. So to illustrate why a set table is necessary, I just wanted to show you an example of this using this here entity table. So this is an entity table. This table's name is sample. We know that because here in the first column, it says sample_ID. So this is a sample table. And you can see on this table that we have multiple lanes of sequencing for this neurons 2K sample. So, and here we have a FASTQ file for each lane of these sequencing, each lane of sequencing. So let's say we want to take all of these lanes in for this neurons 2K sample and output one single output file. If we use this entity table as the root entity, we can't output to the data table because Terra won't know where to put that one single output, because the output belongs to each of these samples, not one individual row here. So in this case, we need to use a set table for our analysis. So here is an example set table. So here was our sample table. This one's called sample set. And now we can see in this table, we have an ID for those neurons 2K samples. And we have an entities column called samples, where we actually list what entities in our entity table belong to this set. Now, if we run our workflow, and let's say we get one output for all 6 of these samples, we can just put that output on a column right next to it so that the output lives in the same row as our set. So that's why a set table can be useful for running workflow and sometimes necessary. Another way of looking at this is illustrated here. So let's say we have 3 samples that we want to run a workflow on, and for each sample, we get 3 outputs. In this case, we could use the sample table as our root entity because we can write back to each individual sample. But if we take in a sample, 3 samples as a set, and then we get 1 output, we need to do a sample set table. So hopefully that makes sense. We're going to be applying this concept to the hands-on portion in just a moment. So if you have any questions about what I just explained, please feel free to ask now. That would be good. And if you're still a little confused, hopefully it'll make more sense as we get through the hands-on portion today. Okay, so how do we actually set a set table to be our root entity? We do that when we do our workflow configuration. So on step 1 of the workflow configuration, it asks us to select a root entity type. If we're going to need to use a set table, this is where we would pick our set table. And then we would select the set that we want to use using our select data. If we run a workflow or launch a workflow on data that's in a set table, it's going to run differently in the background than if we had used an entity table. So here for this example, our entity table is BAM, and then we have a BAM set table. So this is the set table, BAM is the entity table. If we run a workflow on the set table, it's going to initiate one workflow submission for the set. So let's say that we have 2 files in our set. It'll still launch one workflow submission for both of those files. If we were to run those same files from the BAM table, so you can imagine 2 rows of a table, it's actually going to initiate 2 workflows in the background. And just to illustrate this, you can go to your job history and see this. When you look in your job history, there will be a number of workflows column, and you'll see that when you launch the same 2 files with the same workflow, if you launch them using the entity table, you get 2 workflow submissions, 1 for each file. If you launch them with the set, you get 1 workflow submission. So that's just kind of what's happening in the background when you are using the entity table as root entity versus the set table as root entity. All right, so how do you actually configure a workflow to use the root entity table? So let's say you're configuring your workflow and you have a variable that you need to assign. So in this case, on the screen here, I'm showing you a FASTQ file that we need to assign using our data table in Terra. If you're pulling a file from the root entity data table, Terra calls that file using the this dot syntax. So let me go down to this data table here and show you an example of that. Let's say our sample, we're pulling data from our sample table, and we specifically want to pull it from this R1 FASTQ. This is listing our FASTQ files. If our sample table is set as the root entity, then we just use the syntax this dot and the column that has our FASTQs in it. So this is our input column, our R1 FASTQ. So it's pretty straightforward. And you could do that for other columns in your table as well. So that's if your sample table or your entity table is your root entity. This changes slightly if you're using a set table as your root entity. if you're using a set table, you're still going to call your root entity table using the this dot syntax, so shown here. But first you need to tell Terra what entities are part of your set. So you call the column that has your entities in it. So in this example, this is a sample set table. Our entities are listed in this samples column. So we would say this dot samples to tell it to look for these 6 entities. And then we would tell Terra which column has the actual data that we're trying to find. So that R1 FASTQ column. So this dot samples dot R1 FASTQ. So it's just a minor difference in the configuration that when you're using a set table as your root entity, you first have to specify the entities that are part of that set. Okay. All right. So are there any questions about what I just showed you or about how that configuration is slightly different between the two? Because again, we're going to ask you to kind of use this information for this next portion of our workshop. Okay. All right. So let's go into configuring and launching our workflows. And again, I'm going to demo this using the easy puzzle, and then we're going to let you configure the advanced puzzle that you imported from the Broad Methods repository. Once again, the instructions are on the slide for what I'm going to be doing, but I emphasize just watch me for this so that you can take in the information. You don't need to follow any of the steps I'm doing right now. I'm just demoing. So I'm going to go back to my Whittle Puzzles workspace. And now I'm going to go to the data page just to show you what we have in our Terra data tables. So here we have some sample tables that we can use for our Whittle puzzles today. For the advanced puzzle, we have the BAM and BAM set data tables, which you're going to be pulling information from. If we look at the BAM table, for example, we see we have 2 BAM files and we have the file path. So these files live in the cloud, and these are the links to those files. We also have a BAM set table that groups those 2 files together into one set called set1. And if we look at the entities, we can see we have a BAM1 and BAM2 file. So again, these are the 2 that we're going to be using for the advanced Whittle puzzle. But for today's demo, I'm going to show you that hello world script, which again takes in a name and echoes back the hello greeting to that name. So I have a data table here where I have 3 names with these IDs, and the names are actually listed in the hello name column here. And what I want this workflow to do is I want it to take in a set of these names and then output the greeting, hello, Riley, which will be in a text file. I want it to output that text file next to the appropriate name. So we'll create a new column essentially here where each greeting is in the column, is in the new column for each name. So let me show you how we can do that by going into the workflows and going into the puzzle that I brought in. Okay, so here I am on my workflow configuration. The name of the workflow at the top, version number here. Our first step to using a Terra data table is we need to make sure that this is selected, this run workflows with inputs defined by data table. Once that's selected, we're going to pick that root entity type in step 1. So again, the thing I want to analyze is that hello name data table, and it's an entity data table. So I'm going to choose that. But you'll notice when I go to my dropdown, I have those 3 data tables I showed you, but now I also have this option for a hello world name set. That wasn't in our Terra data table section. This is an option because Terra will allow you to create a set table on the fly if you want. But again, I don't want to use this set table as my root entity today. I want to just use the entity table. So I'm going to do hello world name. And then I can select specifically which data I want to use. So I'm going to go into select data. I could process all 3 rows, or I could choose specific rows to process. And I'm just going to, for the sake of illustration, show you 2 rows that I want to process. Now I have the option, when you process more than 1 file, it's by default going to create a set for you, but this does not mean that you're using a set as your root entity. I'll show you what happens when we do this in a moment, but I'm just going to call this set 2 or set 1, yeah, set 2. Okay. So now that I have my data selected, the next thing I need to do is configure my inputs, which Terra pulls from the WDL script that we've brought in. So here's the script if you want to see. I only need to configure the required inputs. Required inputs are in bold. There are no optional inputs for this workflow. And what I want to do is I want to call the name from that hello world name data table. So I'm going to use the this dot syntax to call my root entity table. And when I do that, you'll notice it actually pops up all of the columns that are part of that root entity table. So I'm going to just select the hello name. And then I'm going to save. The other thing I need to do is create an output column for my outputs, because remember, I want Terra to write back to my root entity data table. When you come to the Outputs tab, next to attribute, you'll see this Use Defaults. So you could choose to create a new column that just has the same name as your variable. So I'm just going to show you that. It'll automatically write a new column to my data table, this dot command. So it'll make a new column called command. But if I want to make it personal to what I think the output should be called, I can change this to anything. So I'm going to change it to, I'm going to create a new column called my output. So I do that by saying this dot my output and save. Now I'm ready to launch my workflow. So I'm going to select run analysis. Launch. Okay. Now notice that here on my job history, I've kicked off 2 workflow submissions. Remember, I mentioned if you're using entity as a root table, as your root entity, sorry, if you're using an entity table as your root entity, you'll run a workflow for each file in that you choose. Whereas if this was a set, we would only see 1 workflow submission. Let me go back to the data page and just show you what happens. We're running multiple files from that table. So Terra is going to automatically now create this set table. So remember, before we just had these 3 tables. Now we have this 4th table. What this does is it allows you then to pull these same samples into a workflow. If you want to rerun the workflow on the exact same samples, you can choose this existing set to run on. But because my hello world name table is my root entity table, my output is going to go to the hello world name table. So when this is done running, you'll see a column here that says my output. Okay. Any questions about what I just showed you?
I could have missed this. Is there a way to, so you created that hello world name set sort of by default. Is there a way to turn that off? Or does it always?
Well, if you're running more than 1 file, I don't believe so. You're always going to create a new set to run when you're running multiple files from a data table.
Okay.
That you can keep track of the files that you actually ran.
Gotcha. Okay.
If you were only running 1 file, it wouldn't create a set.
Right, right. Just in this case, maybe it's because of the example, like we don't need that table, right?
Well, you don't need the table to run this workflow, but you could use, now that the set is created, you could use it if you wanted to use an existing set. So like if you're talking about if you have thousands of samples and you don't want to have to re-specify.
Yeah, understood. Okay.
Yeah, so and you would do that just by going back in. You would still have your same root entity table, but now when you go to select data, you can choose an existing set. Now I can choose it.
Okay. Okay, thanks.
Yeah, great question. Okay, so I'm going to hand it back over to you all. I'm going to give to do your own WDL puzzles. Let me go over just really fast kind of the hints and instructions for doing this. So you're going to go to your clone of the WDL Puzzles workspace and go to the Workflows page and select the advanced puzzle that you imported. So it's going to have whatever unique name you gave it when you imported. You're going to need to select on the configuration page your root entity type. And for this, we want you to assume that you want to analyze the group of files in a single workflow submission. You're going to select your data, and you should have 2 BAM files total that you're running your workflow on. You're going to need to configure the required input only. There will be several optional inputs there. You just need to configure the BAM array variable. that's in your workflow configuration. And your hint for that is you're going to need to call your BAM files using the file path column. And then we want you to configure the workflow to write a new column, my output, or an optional name or the default name if you want to use it, back to your root entity data table. So we're going to do this for 10 minutes. So at 1:25, we'll come back and talk about the answers and any trouble spots that may have occurred. Okay. All right, we can review the answers. Go ahead, click on here. Okay. All right, so let's talk about the different configuration parts here. For the root entity, because we said we wanted you to kick off one single workflow submission, you should have picked BAM set to be your root entity table. And the data that you choose, you could have created your own new set if you had wanted to. But if you just use the default, it would have been choose existing sets. You should have selected set 1. For the inputs, because you're using the BAM set table as the root entity, you needed to specify this dot to call the root entity table to find the files that are part of your array. And those file locations were listed in the file path column. So it should have been this .bams.file path. For the output, you wanted to create a new column called my output. So you should have specified this my output, same way we did for the easy whittle puzzle. Your workflows probably haven't completed quite yet, but when they are finished, you should see on your BAM set table on the data page a new column that says my output, and within that you'll see your two outputs. You have a validation report for each BAM file you took in. So you'll see this array in the my output column. Okay, so let me ask a couple of follow-up questions to the group, and let's see if we can discuss a little bit maybe about the different ways we could do this. Could we have configured the advanced puzzle to run using the BAM table as the root entity instead of the BAM set? So does anyone want to try answering that either in the chat or unmuting?
I did that and submitted the workflow. We'll see if it is successfully submitted or not.
Yes. Yeah, so great. I'm glad that you tried that instead of doing the BAM set. So the answer for this one is, and Steve put it in here too, yes, you can configure it both ways. In this case, because we're taking in an array of files, which we're pulling from our entity table, that BAM table, but we're actually not restricted to using a set table because it's not like we're outputting one file for each of those. Each of those individual files will generate a validation report. So you can choose to write that back to your entity table, your BAM table, instead of your set. So this is an example of a workflow that can actually work in both ways. And I accidentally just answered the second question here in talking about that, but if you can use BAM as the root entity, which table would it write to the output to? It would write it to the BAM table, which is what we just said. If this workflow was taking in the array of BAM files and generating a single validation report for it, you would likely need to use the BAM set table to run the workflow. Are there any questions about that? Great, well, then I think we are ready to dive into our break. So we have a 10-minute break right now, and then we'll come back with troubleshooting workflows. And of course, if anyone has questions, we'll be around too. So if there's any off questions that people want to ask, feel free to.
Can I ask you one question?
Yeah.
So I actually tried both, only just the BAM as an input or the BAM set. Mm-hmm. And it looks like the BAM set finished. It worked, but I don't see any additional column on the BAM set data table.
So a couple of things could have happened. One, did you actually configure the output? So the output had to be specified to the set table, to the root entity table. So it would be this dot. So you'd go to your outputs tab, and I can show you this. Let me just make sure. Let me go back here. And
I see. I wrote my output, but maybe I was not at the right data table there.
yeah, so you, let me go into the workflows and just show this on the workflow configure. So you said you used it as BAM set as the root entity.
Mm-hmm.
And then in your outputs, you configured it to say this dot, some output name.
Yes, yes.
And what did you use for your name here?
Just my output.
My output? Okay. And you're saying it did not write back to the data table?
Yeah, I did not.
So sometimes if you go into your job history, sometimes if the workflow, depending on where you're looking in your job history, the workflow can complete, but it hasn't quite written to the data table yet. Try refreshing your data page now and looking at that again and seeing if it wrote to your BAM set data table here.
How do you refresh this?
But you just click on the data page again.
Oh, yeah, I tried that, yeah.
And then you click on your BAM set table. And you still don't have a my output?
No, I don't, yeah.
And your job history, your workflow ran successfully. So you saw.
Yes, it says done, yeah.
Did you for your root entity, it definitely said BAM set. It didn't write to your BAM table as my output.
Yeah, it is BAM set.
Just check your BAM table really fast just to make sure.
Yeah, also the BAM table doesn't have any.
Okay.
Having the same issue.
Huh.
Maybe I am too. Let me see if mine did. No, mine worked. Okay.
Huh.
Could the screen share debugging session if you wanted to do that now, or offline, whatever.
Would you like me to share?
I think so. I mean, I'd be curious, but only if you're comfortable.
Yeah, of course. Yeah, so I have the.
Did you look in the BAM set table? Is that where you, sorry, I'm getting
Oh.
in this a little bit late.
So well, first of all, the
Oh,
BAM
BAM
array,
set, yeah.
the BAM array, so okay, a couple of things. So let's try to maybe configure this together because I see that the attribute, I believe it should be underscore file path with an underscore. Maybe that doesn't.
Oh, here.
Oh,
Yeah.
I bet that dot, because dot tells it to look in the next level down, right? So I bet that is the problem.
Yeah, so it actually should be, wait, oh, sorry.
No,
It should
it's
be
not.
this dot BAMS dot. So this dot BAMS dot file underscore path, but let me confirm on my and that's the actual column.
Yeah, because the dot means
Got it.
after the dot, it's going to look down a level. So it's going to, this dot says, look in the BAM set, right, table. And then it's going to look for the BAM's column in the BAM set table, or then it's going to go down one, right?
Hmm.
And then if you have file dot, then it's going to look for the file column or in, I think I'm not explaining this very well, but I think the dot was the problem.
I see the point, yeah.
And then make sure, I'm sure you have to have data selected for running your analysis. So if you ran, but if you want to try it one more time, you can relaunch the workflow. So select your set. And you can just choose a set that you already ran if you want. Yeah. Okay.
Perfect. Yeah, let's try. So you don't get an error message, but it just doesn't write, doesn't give you the column, right?
Well, I'm surprised it didn't put an error. Would you mind going into the job history tab, like clicking, just click on your job history tab again. And, oh, no, that looks like it ran.
Yeah, it's this
Yeah.
one.
Interesting.
Also, what would it do? If you wrote it to the BAMS dot, whatever, like if you, I'm not sure where it would show up with the BAMS dot even, right? because it's,
What
because
would
it's
be
not,
this?
it's not,
Yeah.
So what happens if you click on the submission in green? Can you click on that for us? The whole line.
Oh, okay.
Okay. And then can you then show us your execution folder, which is the very last folder to the right. So this is like where just all the way to the right, that folder right there.
Oh, okay.
That shows you where things go. So I just want to see if there's anything that got, created. All right. Interesting. So that's an interesting find. I can follow up and see kind of what's going on behind the scenes as to why it didn't error out. But yeah, it's interesting.
Okay. Thank you. Yeah, I'll let you know if the new approach works.
Can I ask maybe a related question really quickly?
Yeah.
So in the solution, how you have it where you started from the set, there's autocomplete for the table, for the entity that you're working from, but it can't go like 2 levels, which is why I didn't do it that way, because I just didn't like think about it. Is it possible to go and like if you did this .bams, which would then go to the BAM table dot and then be able to find file path, or no?
It won't autocomplete for you, so you do have to manually specify. So it'll autocomplete for the table that you're calling, so your root entity table.
Right,
So if
right.
it's the BAM set, yeah, but then it won't go to the next level.
Do you generally have a strategy for like if you need to do a lookup to multiple tables? Like, do you have, because once you start the workflow, I don't know, I guess what I'm trying to work through is like if you're configuring a workflow and you have to maybe do like 4 or 5 of these and don't have the memory to remember like all of the paths, do you have your data open up in like one browser and your workflow in another browser, and that's typically how you do it?
Yeah, you can do that. Yeah, you can
Okay.
definitely. I mean, I often do that. In fact, I usually do that when I'm demoing, so I can switch back and forth between them. But you know, the other thing you can do too is you can set your JSON up more advanced, but you can set your JSON up.
That's right, from a file.
Yeah, right, and just
Yeah.
upload it in there if you've got a lot of stuff you need to specify, and you just want to have both kind of open, like. You know.
Right, that makes sense. That makes sense. Okay, thanks.
If you specify it as like this .bam instead of this .bams, does that, like, what happens then?
You're not actually using like a real column in that case, because it's looking for the column in your root entity table. Your column name is BAMS, so it's looking for that this.bams. If you specified BAM, it shouldn't work because it's not a real column to look into. It won't know where to go.
But like if it's this .bam or this .bams .file path or whatever, like I didn't get an error. That's what I did the first time. I didn't get an error.
Right, but you said you didn't get output, right?
I didn't get output, yeah.
Yeah, so it's something we need to identify kind of why, when it's not specified, you're not getting your output. It doesn't look like, when we looked at the job history, it didn't look like it's actually generating output, but and it's not generating output like from the WDL level, but it's also not outputting them that output to the table. So yeah, I'm not sure why in this case that workflow, for some reason, it seems like that workflow doesn't actually require like input to run successfully. If you do this on other workflows, it definitely will fail. I mean, okay. Yeah, because I've definitely done it. So I'm not sure what's going on with this particular workflow.
Hey. All right, hi everybody. My name's Tiffany Miller, and I'm from the Terra Support and Education team, also a BioData Catalyst powered by Terra Liaison, and I'll be going through the rest of the session. So now we're going to spend some time diving into troubleshooting workflows and figuring out how to estimate your costs and how to get your cost information. Okay, so We talked a lot about submissions and workflows in the last section with Liz. And so we're just going to go over how that applies to some error messaging. So submissions are simply a launched workflow or set of launched workflows. So for example, we talked about this earlier, but you can run a single workflow on 50 samples or entities at once, and you'll have launched 50 workflows when you select the launch button. And you can see that kind of right here in that modal. Or you can run on a set of 50 entities and you'll have launched a single workflow that iterates through those 50 entities. And Liz demonstrated that as well in one of her slides. So when you launch, you're going to see a modal that displays the number of workflows and the version of the execution engine, which is Cromwell, and that's good for reproducibility purposes. And then once a submission has been made, we saw Anthony's screen just a moment ago, and we went to the job history tab to kind of check out what was going on behind the scenes. Essentially, you can see right in the job history tab, basically the status, the number of workflows, some other information. And then when you click on that, it'll take you to this next screen here on the right, and we can then see what data entities we had run the workflow on. And so for here, you can see BAM1 and BAM2, and they were successfully launched. So the point here is that a submission can occur on, a failure can occur on the submission level, the workflow level, or within the tasks of the workflow. And don't be dismayed when your workflow fails, because it will fail. It's just a part of life, doing this type of work in general. So yeah, I think the point of this section is really to get you more comfortable with how to debug when that happens. And hopefully we can do that today. So let's go ahead and look at some of the architecture under the hood to see where failures can occur. All right, so this is a pretty busy slide. So I'm going to try to orient you to how to read it. So when you choose to launch a submission or monitor it in Terra and within the user interface, you can see how this kicks off steps in Terra's backend, which is pictured in yellow, which then interacts with Cromwell, pictured here in red, which is our execution engine. And then finally in the backend, it also communicates with the Google Pipelines API, which is affectionately known as Poppy. So you're going to see Poppy sometimes working in the system, and that's pictured here in blue. The legend here shows you where delays and failures and stuff like that can happen. So if you're wondering, my workflow looks to be done, but the status doesn't appear to be right, these are areas that could be a source of delay. And I'm not going to discuss, every star that's pictured here, but one that I do want to point out is this one, quota. So what does quota mean? Quotas are how much compute and storage the Google Cloud is going to allow you to use. And it's basically how Google prevents someone from taking over the whole cloud and spending $1 million, especially if they're new. So you can, your quota is basically based off of your reputation. So Google will grant you more based off of your customer history. And you can request quota from Google. In general, we have a doc, and I linked it here on the slide so that you can see how to check what your quotas are, and you can see how to request more. And oftentimes, if you do run into a quota issue, you'll notice that there will be like an error message a lot of the times. And so that's when you know, okay, I should go check out, what are my quotas? Where am I hitting a quota issue? And then you can make a request for more. And then the last thing to point out on this slide is that there's some steps here that kind of shows you behind the scenes what happens when you have your workflow and you have your tasks running on these individual VMs. So each basically in your workflow, every task gets a VM in Google Cloud. And so this is kind of the process of what's going on behind the scenes. And once that's done, the task VM is going to shut down, and that's basically what you're going to be paying for, is what happens when that task is running. All right, so let's go ahead and look into the Terra UI and go step by step through the debugging process. Okay, so first, First, we recommend reading the messages in the job history tab. That's right here. If none appear, then you can check out the workflow dashboard by selecting the dashboard icon right here. You know, it wasn't a submission level workflow because there's no messages here. So if your failure happens and you don't see anything there, then you want to take it to the next step and check out what's going on within the dashboard. So here, the dashboard shows us a bunch of red text. It's basically telling us exactly where to look for more information. And it's telling us to go check out this merge tumor pileups log to get more information. So how do we access that? There are a few ways that you can access that. I'm just going to point out to one. So here is a link that will take you to what we call Job Manager. And we recommend that you check out the logs for the task itself and sometimes for the task before. And I'll go into more details as to why you might want to do that. But let's just start off with looking here at what's going on with this task. This particular task and this particular log. So if I go to this icon, I go to Job Manager, I see this nice box here that tells me if there's a failure. I see the same message that I saw in my workflow dashboard down here, but there's an icon that I can click on that's basically going to show me a view of this merge tumor pileups log. And when I scroll to the very bottom of the log, I can then find that a user error occurred. I had an invalid argument. Okay, so that is how we found some information about what happened with this task and why it failed. You can also access the standard error log by clicking on the green folder. Okay, so there's some navigation tips, and all of this stuff will become second nature as you continue to work in Terra and debug workflows and stuff like that. But I'm going to wrap up this section by actually going through some very specific errors that we often see people encounter. Okay, so Poppy error code 9. So what's Poppy? We just talked about that. It's the Google Pipelines API, and it's an error code 9. So what does that mean? This appears when the command block component, so the command block in your task, ended up failing, which generated a non-zero return code. Now, what does that mean, and why is that happening? So this can happen. One reason that's pretty common is a localization failure. So localization means that Terra is attempting to copy the files to the virtual machine that's going to run that command, but it can't. And sometimes it can't because it doesn't have permission to that file, so it can't bring the file over to the machine. So in that case, you want to make sure that you have access to that file and that the path to that file is correctly set in your workflow configurations. Or another reason is that it never got created from the task before that was meant to generate that file that's going to be then used in your following task. And so if the task that failed required an output of the previous task, that's when we recommend you check out that log file for the previous task and see if anything suspicious happened. Sometimes a tool doesn't send the correct error code when it fails, and that's why it appears to have succeeded in Terra. So there you go. You can then, figure out, all right, now I need to see what's going on with this task to make sure that that file gets generated correctly so that it will then localize for this other task. So another way this can manifest is the task failed because of inaccurate tool usage. And when that happens, we recommend consulting the standard error, standard out file for a stack, trace, or exception. And that should give you a hint as to what to do next. Okay, so that is the basics of Poppy error code 9. And the next one that comes up a lot is Poppy error code 10. And this error means that the job exited in such an abrupt way that the machine where the command was running has essentially crashed. And this can happen because of insufficient memory or disk on the VM. So in that case, you want to check what your settings were before, and you want to try to increase them. It can also mean that the job was preempted, though this is less common. And to rule out that possibility, you can check whether the requested machine was preempted and then set that parameter to 0 to retry. And we'll talk more about preemptables. I think this is the first time we're talking about them. So we'll talk more about those in a few slides as to what they are. Okay, and then finally we have job blank exited with return code blank, which has not been declared as a valid return code. What does that mean? So this error is saying that your tool failed in some way, returning a non-zero return code, which Cromwell considers a failure. To troubleshoot that, we recommend searching for error in the log file for your task. And if your command or tool produced a useful error message, you can oftentimes find a solution by just Googling or using whatever search engine you want and trying to dig up what other people have done to get around that issue. And on the support team, we often do that too to try to help our users is just using Google to see. We don't know all of the tools, so we're trying to figure it out with you. Okay, so I'm going to go ahead and move on to discussing cloud costs, but before I do that, I want to quickly ask if there are any questions. I can't see the chat right now, so if somebody can holler, that would be great.
I have a question, and maybe this is what you're going to talk about in a second, but on your little job history, it had a cost estimate, and on mine it says NA.
Yes, I'm definitely going to talk about that. So
Okay.
Basically, we have to kind of change in Terra how we do billing, and we're changing that in the next few months. And so that will allow people to be able to see their run cost. And so we actually have some ways to get around that now with some other tools, and we're going to go over some of those tools today. So short answer is you will eventually be able to see that number. But right now, today, it's not available.
Okay, thanks.
Yeah, no problem. All right. Okay, so in our next section, we're going to discuss a particular workflow that transitions a CRAM to a BAM, and we're kind of using that theme here as well to talk about different ways to estimate how much things are going to cost. So this slide is an example of it shows three different machine configurations that we chose to run this one particular workflow. And we can see that this middle row here that has one CPU and 3.75 gigabytes of memory had the highest runtime, but it had the least cost. And there are many things to kind of highlight here from this example. But before I do that, I want to quickly give a refresher to people who aren't often thinking about hardware and stuff like that as to what these are, what these terms mean. So CPU is the brain of the computer that performs and orchestrates the computational tasks. Memory is holding the information that CPU needs to do the calculations, and preemptible VMs or regular Google VMs, there's a difference between those. And basically, Google is offering what they call a preemptible VM at a cheaper price. And they do that because you're basically giving them permission to say, interrupt your job. So the way you specify that is you specify a certain number of times that you're allowing Google to preempt your job. And by that final, like if you go with 3, you're saying you can interrupt me up to 3 times, but at the third time after the third time, you can't do that anymore. So you get those machines at a cheaper rate. And in this example, we just used one. So one preemptible VM, and we're comparing it with a full price VM. Okay, so some things to notice are that preemptible VMs make a significant price difference, as you can see with these 2 columns. You can see the even greater price difference when you start going with 1,000 samples as to how that can make a difference. Between CPUs and memory, adding more memory is much less expensive than it would be with CPUs. Adding more CPUs can decrease the run times, but that's happening at a significant cost multiple. And if we increase CPU or memory allocations, that can reduce the amount spent on disk because it's shortening the runtime, but disk is the least expensive of the 3 resource types. So those are just some things to kind of call out with this example. And another thing to note is that if you were to just download this CRAM and convert it on your local machine, it costs like about 2 cents. And so that is obviously a lot smaller than how much it costs in the cloud. But once you start getting to thousands of samples, which you're not going to be downloading to your local machine and running workflows on, that's when you can see how the costs shake out and how using maybe preemptible VM makes a lot of sense. Okay, so currently, I mentioned this earlier, but the team is working to expand the ability for everyone to see their cloud costs. You will notice run costs is, they're going to say NA right now in the system. But the resource that we have linked here from the BioData Catalyst collection workspace is called the Workflow Cost Estimator. It's from Beth Sheets' team at UCSC. And they created this wonderful notebook that'll help you estimate costs during your run or after it's complete. So if you're kind of nervous, if you're just getting started, you're like, I'm not sure how much it's going to cost, you can go ahead and check that out. Or you can, yeah, you can check that out and kind of make a decision. There's also an article linked here about how that notebook works and some of the costs that are used or some of the things that are used to help estimate those costs. So I recommend reading the article, and the article also links out to the notebook too. Okay, so let's go ahead and look at ways to optimize your workflows to spend less money in the cloud.
Tiffany, we had a question from the audience.
Yeah.
Could we ask that really fast? Sophie wanted to know how long's the interruption on average?
Oh, that's a good question. I would say you can think of it this way. I guess you're getting interrupted, and then Google should be assigning you to a new machine. So I can't tell you about how much that costs or how much time that is, but once you get a new machine, wherever you left off, hopefully call caching was used, which we talked about earlier. But if you use call caching, you would start back up at where you were before. And I'm trying to think if there's anything else to say about that. Yeah, I think that's what I got for right now. Okay.
Thank you.
Sure. All right. So the first thing to mention with optimizing your workflows to spend less is if you have the ability to use a tool that is NIO compatible, that can make a big difference. So for example, say you wanted to do some variant calling on a specific interval, say it's chromosome 1, and you had 100 aligned whole genome sequence BAMs, the haplotype caller tool is NIO compatible. That's just a GTK tool, and it would stream only chromosome 1 of those BAMs instead of all of the contigs. And this saves time for you to, it doesn't require the whole BAM to be localized. It just streams the chromosome 1 that you need to compute on. So that's a great way to save money if the tool that is provided is NIO compatible. Next thing on the Terra UI that's useful for helping to save money are call caching and deleting intermediate files, and using reference files. I'll talk about that, but that doesn't necessarily decrease costs, but it will decrease your compute time. So let's go ahead and talk about call caching. Liz mentioned it earlier. Essentially, if you check that box in Terra, it's going to detect when a job has been run in the past so that it doesn't have to recompute the results. If it has been run in the past, it's going to copy, I should say, if it has been run in the past and it has the exact same input parameters and Docker and stuff like that, it's going to copy the outputs into the new submission folder for this submission that you're running. And this can save you compute time and money. And it comes in handy when you are testing or troubleshooting kind of a partially failed workflow, because call caching lets you start the workflow again at the beginning of the task that failed, rather than rerunning the entire workflow from the beginning. So that's call caching. Delete intermediate outputs. So this refers to files that are created in the tasks in the middle of the pipeline. And these outputs are not very useful compared to the overall results sometimes. So complicated workflows can have a very large number of these intermediates, which can increase the storage costs, obviously. And we actually found a project that we were working with. They had 85% of their storage cost was going to storing intermediate files that no one ever accessed or used. So they really wanted a feature to be able to get rid of them. So how does this work in practice? When you actually check this checkbox, once you have a successful completion of the workflow is when those intermediates will get removed. If the workflow fails, the intermediate files will not be deleted. So that's useful when you think about having call caching checked as well. Okay, so the third box is reference files, using reference files. So this helps you save time because if you're using or doing an analysis that has the HG19, HG38 references, basically you can check this off, and what happens in the back end is Cromwell is going to append a disk containing these references to your Google virtual machine if it finds them listed in your inputs. And this will save you time, otherwise spent on localizing those files to the VM. And if they're very large, that can take compute time, which you don't want to be spending on localizing if you care about getting things done quickly. So this feature does increase the hourly rate of the VM since additional disk is getting mounted to hold the reference image. So there's kind of a trade-off if you decide if the time saved is more important to you than the higher cost. So figured I'd talk about that since it's right there. Okay, so now let's go ahead and see what can be optimized in the tasks runtime. All right, so as you all know, workflows are made up of tasks. And so in the runtime block, which we have an example of here, this is basically telling Google what size VM you want. And I just wanted to note that there are ways that you can use defaults and not have them listed. So for example, you might be thinking, well, why isn't CPU listed here? And that's because in this example, we're just using the default, which is 1, essentially. Okay, so we can see that there's machine mem size variable that you will set. Here you want to use only the memory your tool needs. And this one's kind of hard. It takes a bit of testing to figure out what the right memory should be and knowledge of what the tool may need. So I think tool providers do try to provide some information like that if it's like a memory heavy tool or not. Okay, under disks, we see local disk. This references the mount point where Google Cloud will localize files. So the local disk will be mounted to /Cromwell-root. And this is just information. Basically, you're never going to change this. For Google Cloud, you have to specify it. So you just specify it. But the things that you can kind of change are disk size and the type of disk. So we recommend going with HDD, hard disk drives, over SSD, solid state drives, because with our own benchmarking, we didn't see that SSD made a huge difference and it's much more expensive. So that's why we recommend that. And then for disk size, we actually have an article about dynamic sizing that we have linked here. And it's basically some code that you can add to your task that will basically figure out like what the disk size should be based off of your input sizes. And so, yeah, read that article if you're interested in doing that. And we'll actually go through an example of that too, some code. Okay. And we already talked about preemptables. We definitely recommend using those. And we recommend using them, especially if your task is going to complete in less than 6 hours, because you're less likely to be interrupted and get the benefit of using a cheaper machine. And something that's cool that was implemented recently is a feature called checkpointing. And we have that underneath preemptibles for a reason. So what you can do is you can use a preemptible machine and use this checkpointing feature. And what happens is if you have like a really, really long job, it allows you to save intermediate outputs for a given task, so that if that task gets preempted, when you relaunch, Cromwell will restart the job from that point in the analysis, potentially saving you hours of work. So there are more details on how to use that feature in that article linked there. Okay, so I'm going to switch gears now and move on to some advanced WDL concepts. I would say they're more advanced. They're not the most advanced, but I'm going to talk about them because you'll see them a lot of times in our kind of best practice workflows and our featured workspaces used in WDL scripts. So let's go ahead and switch gears. Maybe I'll ask, are there any questions before we do that?
There is a question from the audience on, and I didn't know the answer to this for sure. Is there a way to delete some, but not all of the intermediate files?
Yeah, so you could go into the execution folder and delete them yourself. Programmatically, we offer delete intermediates as the option for that. But yeah, you can definitely go in and delete what you don't want to keep. Does that answer the question, hopefully?
Yes, thank you.
Sure. All right. So we're going to go over some parts of the WDL 1.0 spec, and I'm going to go ahead and also pull up a WDL, the creme de bam one, and we can read it together and talk about some of the spec. All right, so some of the WDL 1.0 features that we're going to discuss today are structs. Structs are aesthetically and organizationally beneficial when you have many variables that need to be defined in your workflow. You can essentially bundle them up in a struct and pass them around as task inputs or outputs, and we're going to see an example of that later. Nested scatters are another WDL 1.0 feature. And basically, scattering is how you can parallelize your work with, and with nested scatters, you can basically have a scatter, and then within that scatter, your task can scatter again. And we'll kind of go through scattering. I believe it was covered in Lynn Langett's course, but we'll go through that again and re-explain that with regards to Terra. And then the final thing to note is that you may come across WDLs written in other versions of the language. For example, there's version 1, there's draft 1, 2, or 3. And you're going to know that the WDL is version 1.0 because version 1.0 will be listed in the first line of the file. And then another thing we wanted to share is here's just a little table if you're curious about some of the syntax changes. I believe most of our best practices in our featured workspaces are all in WDL 1.0. All right, so let's go ahead and walk through a workflow together. So we'll do that you can follow along if you'd like by clicking this workspace. I'm going to cover the size, seal, and base name functions from the WDL 1.0 spec. And I think I also forgot to mention it, but there's a link here to the WDL 1.0 spec if you want to read about more useful commands or features of it. All right, so clicking that link brings us here. And we can see our inputs. There's a little bit more listed here than we saw in the advanced WDL puzzle. But we've got our bold ones that are required, and we have our ones in gray that are optional. So if we take a quick glance at this, we can kind of see there's 3 different things happening. We have this thing called cram to BAM flow, which is our workflow definition. We have a cram to BAM task and validate SAM file. So those are 2 different tasks within the workflow. And we'll go ahead and look at the script. So here we can see we have version 1.0. This is again talking about WDL, not about the pipeline itself. We have some nice documentation on this workflow. All right, so Liz did a great job of kind of talking about the structure. So I'll try to go through this pretty quickly, but we've got our files, string, and inputs listed here, or integers listed up here. And then below that, we can see we have our cram to BAM task inputs listed, and we have our validate SAM file inputs listed. So I'll quickly ask, what's different in terms of the input section, like on the left side of the equal sign and on the right side? How do we interpret if those two are different, and which ones do you see are different? Does anybody want to volunteer? Okay, sounds like a no, which is fine. So we'll go ahead and call out two examples. So we've got this Docker image equal to GOTC Docker. So at the workflow level, we have GOTC Docker specified string here. And we're saying in the task, we're calling it Docker image. So set that string to Docker image down in that task. Another one is input BAM is set to cram to BAM task dot output BAM. We know that means that the cram to BAM task produces an output BAM that we want to use as our input BAM to our validate SAM file. Okay. So moving along, we have our output BAMs and our output BAM index, and we have a validation report. So we can see here clearly that the cram to BAM task is going to be producing our output BAM and our output BAM index. And so we're saying for the workflow, that's going to be called the output BAM output bay. And then for validate SAM file, it's producing, we want this variable called report from this validate SAM file task to be set to our validation report file output. All right, moving right along, we have now our cram to BAM task. So we've got some nice breakage here of our inputs for the parameters for the command and the parameters for the runtime itself. Take note that we have hard-coded additional disk size of 20 and machine mem size of 15 here. And now we talked about dynamic sizing. So this looks like it's a little bit separate from, the input section here. And that's all good. We have that set up here so we can do some rejiggering of the variables. So two things to point out are the size function and seal. And so essentially what size is doing is pretty self-explanatory. It's checking the size of the files, and then we can tack on some arithmetic to basically set up exactly what we need. So we have our float output BAM size, is set to, say it was an input cram of 12 gigabytes. We divide that by 0.6, and that's saying that now our size is 20 gigabytes. And then we can see down here that ref size is also set up that way because we're taking the size of the reference FASTA index, and the dictionary, and we're basically adding all of those sizes together, again, as a float. And then finally, to determine our disk size, we are basically taking that output BAM size here, adding that. We're taking ref size that we defined here, adding that. We're taking the size of our input cram, and we're saying add those all together. And what seal is doing is it's basically rounding up to the next highest integer. So this line grabs the size of the input, as I said, the input gigabytes, and adds that to the variables we defined above. And then it's rounding it to the next integer. And finally, we're adding additional disk size, and we have that defined here as 20. So that's basically how we're defining our disk size later on in the runtime section. Okay, so let's go ahead and look at the command block itself. All right, so set-eo pipe fail is a best practice for bash scripts to fail if one of the pipe commands fails. So otherwise, you may get the wrong exit codes when you're piping codes. You'll see this a lot in our best practices. This is useful when you need to ensure all of your commands in your pipes succeed. Otherwise, you may mistakenly get a successful command exit when you shouldn't. So after that, we then see our SAM tool view commands, and those are set up here to kind of do the conversion. And then finally, after that, after the command, we have our runtime section. And here we have Docker image, as we talked about earlier. So that's going to be set up as our GOTC Docker. We have machine mem size, which we had defined earlier, I believe is 15. So that's hard-coded there. And then we have disk size, which we calculated above, and then preemptible tries, which I believe we hard-coded to, oh, we didn't hard-code it here. I think we hard-coded it up here to 3. Yeah, right there. Okay. All right, so I think that's everything I wanted to cover in this section. Where are we? Oh, went too far. That's everything I wanted to cover here. So we'll go ahead and go down to validate SAM file and talk about that. Okay, so the only new thing that we see here in validate SAM file is this base name function. And so what that's doing is it's essentially saying whatever the input BAM is, say it's h11.bam, just give me the beginning of that before we get to the .bam part. So that's saying then h11 will be what gets returned here, and add that to .validation report. So h11 .validation report is going to be our output name. And then again, we see things we've already discussed, so I'll skip that. An interesting thing here that's going on with the dynamic sizing is we have this new variable called command mem size, and it's taking the machine mem size 4 here. So 4 minus 1 is 3, and we're using that here in the command section when we're defining the Java heap size. So that's basically saying allocate the majority of the memory to the Java heap size for this particular validate SAM file tool. All right, and then the runtime section looks really familiar. The only thing different is we see this continue on return code option. And essentially what that's saying is if we get a return code for validate SAM file that's 1, if we don't specify this, Cromwell is going to say that it failed. But we're saying, no, Cromwell, that means everything's still okay. We still want you to continue with the workflow and give us the results. So if you specify that, then it'll work through. And I believe validate SAM file is just, it throws some warnings when it returns exit code 1. So anyway, that's something to keep in mind for whatever tools you're using. Okay, and then finally we have the output name, which we defined up here. Okay, any questions about this WDL? The last thing I'll say that it's kind of interesting is because we have hard-coded some options, if you look in the input section, they're going to show up as optional because they already have a value, but you can override them. So that's nice if you want to use like a different Docker image, for example, or change the sizes of the machine or disk if it makes sense to. Okay, then I will keep moving along. All right.
Sorry, I have a quick question. I clicked on the link in the slides, but it just took me to Terra. And I can't, how do I find the workspace? Can I clone this workspace?
You can. Can a TA throw the link in the chat?
Yes, we'll grab it.
Thanks.
Thank you. Yeah, that's part of our sequence format conversion workspace, which has a lot of like handy WDLs for doing format conversions.
I have a question. So we had talked about using R in like a notebook. If you're using R and like, calling an R script in WDL, would you need to like get an R Docker?
Yes. Mm-hmm.
Okay. And then can you do that? Okay. All right. Thanks.
Yeah, you can find, I'm sure that there's some publicly hosted options for you to use. So you don't have to create your own, which is nice. So you could try that. Any other questions? Okay, I will keep moving then. All right, so the next few slides are WDL features that you'll see again utilized a lot, so we want to talk about them. This is a quick example of what import statements look like in a workflow right here. In order to support the composition and reuse of workflows, WDL allows the execution of an entire workflow as a step in a larger workflow. So when we do this import business here, we basically call these items sub-workflows. And to find the location of them, you can look at the number of forward slashes to see exactly where those are stored. So for example, GitHub repository in this case is where these are stored, and this is a doc store workflow. So if I go in the Terra and the workflow section, and I see this, I can click on the source code. It'll take me to doc store, and then doc store also has an option to click on the source code. That'll take me to the GitHub, and I can find this particular folder path and locate where that WDL is. And sometimes that's handy if you're kind of curious, as to maybe you had a failure and you're trying to kind of understand what happened in a WDL that was imported. So want to make sure to describe that. Now, if you're using the Broad methods repository, essentially what you'll have to do is you'll have to check a checkbox that says that you'd like to make your WDL publicly available. And then below that, there will be an import URL. And that's what you would use to import that into your other workflow. Okay, so notice here that the last line points to a WDL that we call DNA-seq structs WDL. So let's go ahead and look at that. So a struct is a C-like construct which enables you to create new compound types of previously existing types. They are custom built by the workflow author and enable the author to bundle groups of variables into a single variable so that it's easier to pass them around. And in this workflow, for example, this particular one, whole genome germline single sample pipeline, it has 45 input variables in the input section, and that makes it really, really difficult to read. So what the author did was it created a structs WDL where it has all of these different structs where they've tried to group together those inputs in a way that makes sense, and that is sort of a best practice. So here you can see we have all of our reference FASTA inputs listed here in this struct. Okay, so that's what all I wanted to cover was structs. And now I'm going to quickly go through and talk about scatter gathers. I'm using the example somatic SNVs and indels for GATK4 to kind of talk through this. So the scatter function is from the WDL standard library, and it produces parallelizable jobs running the same task on each input in the array. Like here, step A is happening, for example, with three different input files. And even though the output of step A looks like a single file based on its declaration, if you refer to step A.out in any other call statement, it's sufficient for WDL to know that you mean the array that's grouping the outputs of all the parallelized step A jobs. So all of that to say is that scatter is explicitly stated, whereas gather is implicit. And so you're not going to see gather anywhere. You'll just see scatter in the code. So yeah, so behind the scenes, step A, each input file in the array can be spun up on a separate VM in parallel, and essentially step B will be happening, and it'll start once the output of step A for all of the machines is complete. And to kind of illustrate that further, here's what it looks like at the workflow level. So we see that split intervals is first, and we have this intervals file that we're giving to split intervals, and we're basically defining this thing called a scatter count. So say we define that as 50. So what split intervals is going to do is it's going to chunk out that interval file into 50 equal intervals. And then what it's going to do is it has an array, and then it's going to pass that, see split intervals.interval files to this scatter subintervals. And basically what's going to happen is it's going to spin up 50 different machines with Mutex2 running on each of those 50 input interval files. And then once that is complete, it's basically going to then run merge VCFs. We can see here that the input VCF is M2, which is the task here, dot unfiltered VCF and unfiltered VCF index. So these two are required for merge VCFs to start. Okay, so any questions about this scatter gather situation? Cool. So I will end this section with talking about some recommendations for developing WDLs. So we recommend that you develop and test locally, because running it in Terra, as you can see, requires a few more steps. You had to import the WDL into either doc-store or the methods repo, the Broad methods repo, and then you have to configure it, and then you have to launch it. And so that's kind of a lot to figure out that you have a syntax issue or a typo somewhere. So you can validate your syntax locally with WOM tool, or we recommend using MiniWDL, and that's a runner and Python development toolkit built to accelerate the code test debug cycle. Its runner can be employed for small to medium data production use cases, and its library helps Python developers create further complementary tools. So there's a getting started tutorial that we linked here. And you may have noticed, if you were taking Lynn Langett's course, that she actually also has a course on using MiniWDL. So I think we linked that here as well. If you use VS Code or IntelliJ, different IDEs, there are some WDL plugins that you can use too. So we've linked that there as well. And we have some other WDL resources on GitHub that we've linked for you. Once you've got things working, you can upload it to Terra and kind of iterate. We always recommend testing your workflow end to end, maybe on 1 or 2 samples, and then you can, go see how much it cost and how much time it took, make it the way you want, and get a pretty good idea on the cost, for example. And then you can kind of estimate, if you were running it on 10 times the amount, how much is it going to cost? 20 times the amount, how much is it going to cost, etc. Okay. So I'm going to wrap things up, but before I do, are there any questions? So wrapping up the section, there's some optional homework that we have listed here and in the syllabus that covers doc-store, which is an excellent resource for storing and versioning your workflows and tools. And it's definitely encouraged as a part of the BioData Catalyst Consortium to be storing your workflows there. So there's a link also to a workshop video and some documentation on how to bring your own tool. So we definitely recommend checking those out after this workshop. And we will end with any other Q&A people might have. And I will go ahead and stop sharing so that we can see each other. Well, if there's no further questions, we could end pretty early. Oh, Liz, you wanted to talk through what happened earlier. Thanks.
Yeah, so a couple of our audience members pointed out that they were able to run the advanced WDL puzzle successfully on the job history, but they didn't get any outputs written to their data table. And when we went in and looked at this, we identified that the problem was that we didn't specify inputs correctly, but the workflow still ran successfully. So I just wanted to kind of share really fast an example of what happened and talk about why the job history shows a successful run, even though we didn't get any outputs from our workflow. So here we are, we're in the advanced WDL puzzle. The area that we specified incorrectly was this BAM array. There are various ways people could have specified this, but if I'm just going to type this.bam, which isn't actually a valid column for my root entity here, which is the BAM set. But I can still type this in. Oops, let me actually change it up here because let's call it this.bam.portal and just hit save. this is not a valid input. If we go and look for this input somewhere, our Terra won't be able to find it. When we tried doing this and ran it, let me just show this really fast. If we look at the job history for this run, you'll notice there's no list view here on the job history. So when all tasks run through when you submit your workflow, the tasks that ran will be listed in a list view, and I'll show you that. All right, here is an example of that. So here's that easy whittle, and you can see we have a list view here with our timing diagram, and you'll see the task name written out. But when we look at our job history for a successful run that didn't actually give us the outputs, we don't see that list view here. And what we do see down here is that the BAM array that we called is null. There's nothing specified in here. So why did the workflow run and it didn't fail? The reason is because if we go to the script of that workflow, we have no validation point for our inputs in this workflow. So you can validate inputs in your workflow. And you'll notice the task, the call for the task is embedded, is nested inside this scatter. So when the workflow went to do scatter, it actually didn't have a BAM array. So it just skipped over the task entirely, and that was it. So from the workflow point of view, nothing was wrong with our workflow. So it looks like it ran successfully. But in reality, we just didn't get any, outputs because we never called our task because there was no input to be found to run the task, to scatter and run the task. Go ahead.
Does this suggest that you should have some sort of like error in the workflow, sort of an error flag? If it doesn't have the items defined, then it should basically like abort and stop the way that other programs might have?
Yes, you can choose. So some workflows, and we can certainly find an example of this and maybe send it to the group. Some workflows will actually have a whole step dedicated to validating the inputs to make sure that inputs are correct and the workflow can proceed. So yes, specifying in some way. If this workflow had a next step to it or something where the outputs of this were required, the workflow would have failed on that step. So yes, I just wanted to emphasize that, if this task hadn't been nested in a scatter, if we had a separate task and we didn't provide input for it, it would fail in the job history. You would see a failure for it.
Can I just mention earlier my question about the input, like related to what you just said? So when I switched, I think it was Ali's suggestion, or when I switched the dot to underscore, it worked. So I think that was the issue with my input. However, the thing I wanted to ask is that when I run it as a BAM set, I got under my output, under the column my output, I have now 2 items. And I'm wondering why I have 2 items and not 1. Shouldn't it be only 1 item coming out?
It is 2 because you actually are getting an array back. So you're getting a validation report per file. That's the way the WDL is written. So you are getting back the array of files. It'll produce 1 validation report per BAM. And so you get back the full array. So again, this is an example where the workflow, you didn't have to run it as a set, but I wanted to show you that you can run it as a set. But there are other in the scenario where you were just getting back 1 output, you would have no choice but to run it as a set. But in this case, you have a little flexibility in how you want to run it because you're getting back 1 output per sample.
Got it. Thank you.
Yeah, I think that really just hits home the idea that you definitely want to look at your workflow and what your workflow is doing as you're thinking about how you're going to set up your data to run it.
Perfect.
Any other questions? Okay, I think we could probably end early then. Okay, awesome. Thank you everyone for attending, and thank you so much for filling out the survey, and we'll be in touch soon. Have a good rest of your day.